Ouais. Bonsoir à tous. Merci Edwin pour cette introduction. Donc je vais commencer par deux petits mots sur l'organisation de cette soirée qui sera divisée en fait en deux parties. Il y a une première partie où nous avons invité trois scientifiques, dont deux auteurs contributeurs au rapport du GIEC, pour vous expliquer les éléments saillants de ce rapport, ce qui est neuf dans ce rapport et ce qui est pertinent pour notre discussion de ce soir sur l'ambition, l'urgence de l'action et les modalités de la transition. Ça, ce sera la première partie scientifique. Et ensuite, dans la deuxième moitié de la soirée, nous avons invité donc 4 invités de marque, dont 2 représentants du monde politique, 2 représentantes de la société civile, que je remercie d'avoir accepté notre invitation et d'avoir pris sur leur précieux temps pour nous rejoindre ce soir, et qui vont donc débattre autour de quelques questions que nous leur proposerons. Et nous n'oublierons pas le public, donc vous serez également invités. Vous êtes très nombreux ce soir. Je suis désolé pour l'inconfort pour certains d'entre vous, lié à la taille de l'auditoire, malheureusement, mais donc je me réjouis que vous êtes nombreux, et bien sûr, nous vous donnerons la parole dans la deuxième partie du débat ce soir. Et donc pour commencer, je vais donner la parole à notre premier invité scientifique, que je ne vois pas, Joeri, où es-tu? Voilà. Joeri Rogelj, qui, donc je vais prendre mon petit papier pour être sûr de ne pas tromper dans votre affiliation. Donc vous êtes actuellement professeur invité au Imperial College de Londres, si je ne m'abuse, dans le Grantham Institute. Vous êtes l'un des auteurs du chapitre 2 du rapport spécial du GIEC, consacré donc aux trajectoires d'émissions et au budget carbone lié à l'objectif d'1,5 degré. Et vous allez nous présenter ce soir donc votre contribution à ce rapport et des éléments de ce chapitre. Alors je précise également que Monsieur Rogelj n'étant pas francophone, il va faire sa présentation en anglais. Le reste des interventions pour ce soir seront en français. J'espère que ceci ne posera pas de problème pour le public. Donc je vais vous passer le micro et nous allons installer votre présentation.
Okay. Yes, good evening. Thank you very much for the invitation, and I'm really happy to be able to present here some of the insights of the 1.5 special report. Malheureusement, mon français n'est pas assez bien, ou mon français technique n'est pas assez bien pour faire cette présentation en français, mais si vous voulez, vous pouvez bien demander des questions après en français, bien que je pense que je vais répondre en anglais quand même. So, I was asked to talk about the implications of a 1.5 degree budget target for carbon budgets and for emission pathways, and I want to, in the next 20 minutes, I want to look at this issue through 3 questions. And these 3 questions are, where are we today? How much carbon can we emit? And then, how do we stay within this carbon budget? And these are 3 questions that have been covered in the 1.5 report in Chapter 1, and in Chapter 2, where I was one of the coordinators. So let's start and have a look at where we are today. What I'm showing here is the very first figure of the summary for policymakers of the 1.5 report. And what it shows is global mean temperature over time since the 1960s. And what you can see is on the left-hand side, you can see this very wiggly and very noisy data going up. And this is actually the observed monthly global mean surface temperature. So this is observations. This is what we see in the real world. This is what we can deduce from measurements on land, on ice, in the ocean, and so on. And what you can see is that it's very noisy. There are periods in which it goes steeply up. There's periods at which it stays rather constant. There's even 1 month that already went over 1.5, as you can tell. And that's really interesting, but it's particularly interesting for the orange area that is plotted on top. And that orange area that is plotted on top is the human-induced part of global warming. And what you can see there is that most of this increase in warming is actually the result of human activities. And already by today, we see that human activities have resulted in about 1 degree of warming, and if we compare then that 1 degree of warming to where we are today, and if we just extrapolate the recent trend, you can see that soon we would be hitting 1.5 degree of global warming. This already gives the first indication of where we are today and the urgency of actions to limit warming to 1.5. The next question, of course, is if we know that we are so close and that we are increasing so quickly, is it geophysically possible to limit warming to 1.5? Is within the laws of physics and chemistry, are we able to keep the temperature under that level? And for that, the report did a few thought experiments. In the first thought experiment, they reduced global CO2 emissions from today's levels to 0 in 255. And what you see on the right-hand side, the gray area, is the projected temperature increase. And you can see that some of that temperature is above 1.5 and some of that is below 1.5. The report also looked at what would happen if we reduce CO2 even faster, actually by 2040. And if we reduce global CO2 emissions to 0 by 2040, you can see that in the long term, we would definitely have a benefit of this faster reduction. In the near term, we still have a high probability that we would be exceeding 1.5. And finally, in all these pathways, we assume that not only CO2 is reduced, but also other gases like methane, nitrous oxide, and aerosols. Now, if we keep those constant, even then, actually, there is quite some probability or quite a possibility to limit warming to 1.5. So this was a very important first part of answering the question where we are today and to see whether it is possible to limit warming to 1.5. So to conclude this part, the report concluded that human activities have caused approximately 1 degree of global warming to date since pre-industrial times. So that's since 1850 to 1900. The impacts of this warming can be observed and are felt by society and by biological systems. And importantly, as you could see in the previous slide, the effect of past emissions will persist for many centuries to millennia and will also continue to contribute to further sea level rise after this century. And the next presenter will be speaking more about this. But very importantly, emissions today do not commit us to exceed 1.5. So that really means that whether we exceed 1.5 or not really depends on the actions we do today, tomorrow, and the day after tomorrow. What we did in the past does not commit us yet to exceeding that level. However, at the current rate of warming, we would be exceeding 1.5 around 2040 with a plus-minus range of 10 years. And importantly, to halt global warming, be it at 1.5, at 2, at 2.5, or at any other level, global carbon dioxide emissions need to be reduced to net zero, and non-CO2 forces like methane and other greenhouse gases have to be strongly reduced and decline. So now that we know where we are today, and now that we know that we're very close to 1.5, the question is, of course, how much more can we emit? And for this, the report looked into carbon budgets. As was already mentioned in the introduction, the carbon budget is the total amount of carbon dioxide that can be emitted while still holding warming below a certain level. So if we stay within that budget, then warming would be stabilized at the intended level. So, and the concept of a carbon budget has a few very simple implications. The first implication of the carbon budget concept is that, what I already mentioned before, to halt warming to any level, global carbon dioxide emissions need to become zero. Another very simple consequence is if we emit more in the next 10 years, we will have to go faster down afterwards to stay within the same budget. This is simple arithmetic, but it is a very important insight to be able to say that any year of delay will make it harder and more difficult 5 or 10 years from now. And then finally, if a carbon budget is exceeded, and we exceed a certain level of warming, then the only way to return warming or to reverse this kind of warming is to use carbon dioxide removal. That means actively removing carbon dioxide from the atmosphere through technologies that are called negative emissions technologies, and which are a huge challenge to be implemented. So this brings us to the question, how much carbon can we emit? And I want to show this, the insights of the report, with this very simple graph. This goes from 0 at the bottom to 1.5 degree of global warming at the top. 1 degree of that 1.5 degree we have already emitted, or we have already seen through emissions, through past emissions. So there is only half a degree left. From that half a degree, we expect about 1.1 to 0.2 degrees to be taken up by future warming of non-CO2 greenhouse gases, particularly methane, and the reduction in aerosols. So that means that only a very limited amount is left for carbon dioxide. Now, what is the size of that budget? Was also already mentioned in the introduction. Here you have the actual numbers. To have a 50% chance to limit warming or to stay below 1.5, we would have to limit future carbon dioxide emissions to 580 billion tons of carbon dioxide. To have a slightly higher, 2 out of 3 chance, we would need to limit them to 420. We also understand much better the uncertainties around those. There is a large uncertainty because we are so close to the limit. There is a geophysical uncertainty of plus minus 400 gigatons, and then also an additional uncertainty depending on what we do or whether we are successful or unsuccessful in reducing other greenhouse gases. For context, by the end of last year, we had already emitted 2,200 gigatons, and currently we are emitting 42 gigatons a year. That indeed means that the 50% chance budget would be exhausted in about 15 years. And if we want to stay within that budget, and we start declining now, we have to reach global net zero emissions by 2050. Again, this is just simple, a straight line from today to 0, then you would stay within 580. So the last part of this presentation, I want to do to look at what the report says on how do we stay within this budget. How can we transform society so that we actually limit carbon dioxide emissions in this quite stringent budget. And for that, the report took information from a lot of studies that in the literature that modeled how society can transform, how the energy system can transform, how the land system can transform, how the transport system can transform, and that looked at it in an integrated way, and then provide so-called scenarios. And we grouped those scenarios based on their ability to limit warming to 1.5. And here, in this figure, you can see the global emissions in those pathways, the global carbon dioxide emissions for all pathways that limit warming to 1.5 or close enough to 1.5 to be within the uncertainty bound. And what you can see is a couple of clear characteristics. First of all, there is a robust decline in the first decade. After 2020, all those emission pathways see emissions decline very steeply, around 40 to 60% relative to 2010 levels. There are varying levels of carbon dioxide removal in the long term, and the amount of this carbon dioxide removal depends on the level of ambition in the near term. The interesting part, however, is that all those pathways roughly meet net zero emissions by mid-century. So if there is one milestone that all those scenarios have in common, that is really that they start this trajectory as soon as possible and that they aim to reach carbon neutrality by mid-century. Now, these are emission lines. What does this mean for the rest of society? The IPCC is very good at finding very crafty words. And this is one of those sentences where the IPCC found that limiting warming to 1.5 would require rapid, far-reaching changes at an unprecedented scale. And each of these words means something specific. Rapid means in the next decade. Far-reaching means in every sector. And unprecedented means that the changes that would be required have been seen in some sectors, in some countries in the past, but have never been observed globally and in all sectors. So this is a huge challenge, and this challenge would have to lead to deep emission cuts in all sectors, would require a range of technologies. There is no one single silver bullet that will solve everything. It will require behavioral changes, and it will require a very strong shift in investments towards low carbon options. Just to give you a few numbers and give you a little idea of what that then means, by 2050 fossil fuel supply would only supply about 30%, but a range of 0 to 55% compared to of electricity. So compared to today, today they supply around 60 to 65% globally. Emissions in industry would have to decline 75 to 90%, and the share of low emissions or low emission final energy in transport, basically the amount of cars, electrical cars or biodiesel cars or biofuel cars or hydrogen cars that there are on the street, would be 35 to 65%. So that from less than 5% today. So these are huge challenges, these are huge changes. Putting this again a bit more in context, it means that the progress we have seen recently in renewables should be mirrored in many other sectors, in the industry sector, in the transport sector, and so on. We would also need to start taking carbon dioxide out of the air, either by natural means, reforestation, afforestation, or by technological means, by combining bioenergy with carbon capture and storage. However, the report is very careful here. It says that planning to temporarily exceed and later return to a certain temperature threshold through carbon dioxide removal is extremely risky and entails really large challenges, because it also links to food security, ecosystems, and biodiversity, and I will come back to this later. So this was all very, so this is very aspirational. This is what should be done, and this is what should be done to limit warming to the most stringent target that is included in the Paris Agreement. Well, maybe it's time, just before the end of my intervention, to do a quick reality check, and spoiler alert, we are not on track. The IPCC report finds that the national pledges under the Paris Agreement would lead to around 52 to 58 gigatons of carbon dioxide in 2030. That is a stabilization of slight increase compared to today. However, 1.5 degree pathways show a halving of emissions until 2030. So it's clearly that what is currently on the table is far insufficient to reach any of the pathways that I have just presented here before. What I showed you until now are very general characteristics and of all the pathways. However, one last point that I want to make is that all pathways are not the same. And the report illustrates that all pathways are not the same by using 4 illustrative pathways. And what you can see here is 4 pathways, each of which achieve the 1.5 degree goal in some way. And you can see how they are achieved in very different ways. The gray area shows fossil fuel emissions. The brown area shows afforestation or land emissions, if you do land management and so on. And the yellow area in those graphs shows the amount of carbon dioxide we are removing from the atmosphere through technological means, by combining bioenergy with carbon capture and storage. And you can see that in some pathways, let's say the bottom left, the P3 pathway, there is kind of a mix of all options. However, what the report also finds is that if we are not able to improve energy efficiency, and if we continue to use lots of fossil fuels, we will end up in the right-hand pathway, where we really rely and we require high levels of carbon dioxide removal. And this is problematic because carbon dioxide removal, or some ways of doing carbon dioxide removal, come in competition with food security, water security, and sustainable development. So finally, mitigation choices matter for sustainable development. Depending on how we try to limit warming to 1.5, we can do a really good job, or we can do a really bad job for sustainable development. And this is something that the report looks into detail, and I think Henri, one of the next speakers, will further elaborate. So concluding what we have been looking at here, where are we today? We are at 1 degree and we are heading for 1.5 by 2040, with impacts already being observed and felt all over the globe. How much more carbon can we emit? You can forget the numbers, but remember that it's very little. And it basically implies, to stay within the budget, implies that we go to net zero, or zero emissions globally, by 2050. And now finally, how do we stay within this budget with rapid, far-reaching, and unprecedented action in all sectors? Finally, the report is also very clear that climate action and sustainable development can go hand in hand, but that particular attention from policymakers has to address this issue, otherwise it might also well not be the case. Thank you very much. If you want more, please do read the report, download it. The summary is very accessible, and the report otherwise has lots of detail on specific issues, specific technologies, specific sectors. So thank you very much.